So now I'll be setting up the same cantilever beam problem to determine the influence of material and load uncertainties on the deflection at the end of the cantilever beam. The Monte Carlo analysis that I'll be setting up will be shown here in a graphical interface for Isight, and the window you're looking at is the SimFlow window of Isight Design Gateway. We'll start off by pulling in the Monte Carlo component from the Process Component tab into our empty workflow loop, and then go to Application Components, and then we will drag in the Abaqus component tab into the loop. Now we want to open up Abaqus. Within this Abaqus component, it's got its own interface, which first asks for the input file of the Abaqus model. So we want to open that up and then find our input file. After selecting the file, you want to read the file. Isight will find all scalar values from the input file and display them in this table, as you can see here. So we will be selecting the Young's modulus and concentrated load parameters because we want to make them into distribution inputs. So here we would want to check Young's modulus and C load. Then we click apply. So now we want to go to execution tab, and in it Isight is calling out Abaqus commands, and all these stuff are generated automatically, so there's not much we want to do. One good thing to do is to uncheck the save output file database. This will eliminate Isight saving every single output file during its runs, and for small jobs it will be okay, but if you have jobs that takes hours to run, it's gonna fill up your hard drive quickly. And then you can also check the option of storing your input file in the model. Now go to the output tab. Similar to the input tab, we will need to select the file. In this case, it will be an output database file, which is obtained from the first deterministic simulation of our Abaqus model. So we want to go to browse again and find the output database file and read in the file. So we need to select which output we want Isight to evaluate. Here we will be selecting the maximum deflection of node number 101. This node is located at the free end of the cantilever beam. This is what we are going to use to evaluate the uncertainty of our cantilever beam system and measure how variation affects the deflection. So we want to find the minimum from node 101, check that, and then click OK. So now we come back to our SimFlow window. We now want to open up Monte Carlo component, and in it we need to select a technique. There are a total of 3 available techniques. Simple random sampling is a traditional Monte Carlo analysis, and then we have descriptive sampling. This is a reduction technique similar to Latin hypercube sampling, which reduces the total number of runs that we need to do. And then the last technique is Sobel sampling, which is a more uniformly distributed sampling technique than the other 2 mentioned earlier. This Sobel sampling technique creates a close approximation to the true density function, and in our case we will be selecting the simple random sampling just to stay consistent with the other 2 analyses that we ran in Nessus and MATLAB. So we select that, and then for the number of total simulations, we will put in 10,000. Under the execution options, right here, we're going to leave everything as it is, but just to talk about the options, the execute Monte Carlo sample points in parallel is to run two analyses at the same time. In our case, this will be running two Abaqus components or Abaqus jobs at the same time. And then for this one, with the next item checked, Monte Carlo analysis resets itself to the mean value before the next iteration. Convergence check interval is set to 25, and then the convergence tolerance is set to 0.001, which is 0.1%. These two values are set by default. It compares the mean. So Isight calculates the mean and standard deviation for all sample data points at a 25 iteration interval in this case. And then what it does is it compares the mean and standard deviation values with those calculated from 25 iterations ago. If the percent differences are below the specified 0.1% threshold, the analysis is considered to be completed. So now we want to move on to the random variable tab. So in here we want to check both variables, and then for concentrated load, it will be a normal distribution with a mean value of -200 and standard deviation of 20. For Young's modulus, same normal distribution with a mean value of 7e to the 10 and then a standard deviation of 7e to the 7. Okay. So after you set all of the distribution information, we want to move over to the response tab. You can specify an upper limit, lower limit, and percentile. But in our case, where we want to have the entire distribution, we'll just leave all these three blank. So now we want to click apply. Okay. And after that, we want to go to data flow to check if the data are flowing the right way into the right components. And here, as you can see, our Monte Carlo components are outputting C load and Young's modulus into Abaqus components into the same variable names. As you can see that our output here is not linked back into Monte Carlo. This is telling me that I missed checking one of the components. So we come back here, go to our random variable, and then response. As you can see, I forgot to check the maximum deflection. So come back here and check it real quick, and then go back to my data flow. Now, after each simulation, Abaqus is going to output its maximum deflection value and then send that information into Monte Carlo. So then Monte Carlo will be able to evaluate the variations of my deflection output. So after that, we are done configuring both the Abaqus Monte Carlo components. Usually the next step is to go up here and click run. But as we mentioned multiple times in our presentation, these kind of analyses takes hours to complete. So we will just go ahead and go back to our presentation and show you the results from a previously ran Isight job.